Okay, you've got what looks like a polynomial equation here, except that we have some absolute value symbols. Over here on Desmos, I've graphed this function, the left-hand side of this equation, and it turns out the zeros are at -2, -1, 1, and 2. The question is, how do you determine that without a graphing calculator? Well, if we let u equal the absolute value of x, we have a polynomial equation that looks like this, which it's possible that there's no rational zeros, but we can test to see using the rational root theorem, or the rational zeros of a polynomial. So if the polynomial has integer coefficients for every term, well, this one does. The coefficient of u cubed is 1. Coefficient of u is -7. The coefficient of u squared is 0, by the way, and the constant term is 6. So this theorem applies. The numerator of the rational zero will be a factor of the constant term. So if c over d is a rational zero, then c will be a factor of the constant term, which is 6, which means these are the possible numerators of the rational zero. And the possible values for d will be, well, the factors of the leading coefficient are just plus or minus 1. And by the way, this ends up being the set of all possible rational zeros. Of course, normally we would just test to see if you put 1 in for u, do you get a true statement? And we do, because you get 1 plus 6 is 7, minus 7 is 0. If you want to find the remaining or the residual polynomial when you divide by x minus 1, you can use synthetic division. Those are the coefficients of the trinomial factor that remains. And so you can factor this into u minus 1 times u squared plus u minus 6. It turns out that that trinomial factors also into u plus 3 times u minus 2. There's the completely factored form of the left-hand side using the zero product property. U is 1, or u is -3, or u is 2. And we already said that u was the absolute value of x. So if I replace each of these u's with the absolute value of x, I can solve each of these equations for x. Of course, there is no number you can plug in here that will have an absolute value of -3. So this is not going to give us any solutions. But if the absolute value of x is 1, then x is 1 or -1. And if the absolute value of x is 2, then x is 2 or -2. Okay, so those are the roots of the original equation. And this graph kind of proves it. There you go. Hope that helped. If you have any questions, post a comment.